specifically in this video, we're going to talk about DeFi, decentralized finance on top of Ethereum, and how we can algorithmically trade between different cryptocurrencies that might be pegged to stable coins or traditional Forex assets or stocks or whatever, as well as use leverage, take a certain side of the trade, long or short, as well as just doing run-of-the-mill trades. And in the end, we're going to make a transaction that's going to mimic this one, in which we're going to send over some Ether into the smart contract, and then it's going to use decentralized marketplaces to purchase DAI stablecoin, which is just a Ethereum token that's tied to the value of the dollar. So we're going to execute that trade by deploying a smart contract that looks like this, that actually executes that. So really, we're going to look at this logic here to buy DAI, call the smart contract for DAI, initiate an exchange, send over some money to that exchange, and in one synchronous way, get the funds and then send that back to the user who sent us the money. And we can, the cool thing about this is that we can then later take the same token and trade it on another exchange right after. So we can buy it on one exchange cheaper, and then right after sell it on another exchange more expensive. And we can then automate the finding of this and the execution of this using our node application, which looks like this. So this is our application that's actually going to call our smart contract, and we'll also talk about how to put that on the cloud. So there's going to be a lot of covered in this video. Hopefully we're going to get this in really quickly, but one of the key pieces to remember is this video is going to move a little fast, and we're going to cover a lot of ground, but it's going to be all the pieces that you need to get started with your smart contract development, as well as your DeFi usage in regards to plugging into other platforms, pulling data, as well as getting libraries. So this video is meant to be watched over and over again, because I don't imagine that most people, if you're brand new to programming or if you're brand new to DeFi, this is going to be something that you're going to watch once and then say, and you could be a genius, in which case, great. But just FYI, it's going to move really fast. We're going to actually just do all of this really quickly. So let's start with the smart contract. The first thing we're going to do, now I'm using a platform called Atom, which you can download a Solidity viewer. So Solidity is the programming language that Ethereum uses, and that's the programming language that you'll need to understand in order to write smart contracts. There's also Viper, but most programmers code in Solidity, so we're going to be using that. And what I'm going to do here, we're looking at a Solidity smart contract. I'm going to take pieces of this, for example, this chunk, and I'm going to make it, I'm going to collapse it, or rather fold it. I'm going to fold this one as well, because these are just libraries that we're using that actually get the entire application to work. So none of this is our code. This is just an interface that allows us to, for example, interface with the Uniswap exchange, ERC20 tokens, and the ORFeed Oracle for pricing data. All right. So we're using those. We'll talk about those more down the road. The main thing that we're doing here, our smart contract that invokes the above libraries, is just this little piece of code. It's about 25 or so lines, right? 28. Lines of code. Okay, and so we're going to focus on this, and a lot of that's just commented out. There's very little. So we're going to go over what this does. So it's a contract, has a name. This is arbitrary. You can name your contract anything. This is called the Uniswap trade example. And then what we do then is we create a function. Now, function is just something that does something, and this one's called buy DAI. What we'll talk about also is how you can get this code. I'm going to swing over here to my terminal. So if you have a Mac, you'll be on the terminal. If you have a PC, you'll be using the equivalent of a Mac terminal where you can just enter commands directly in. But this will be mostly for Mac/Ubuntu users. You can still follow along if you're kind of familiar with coding and stuff like that. The first thing you're going to want to do to get started is switch into a directory. I usually go into my apps directory where I do everything. And you're going to do a Git. Now, if you don't have Git and you're going to be working with this stuff, you'll need to download that. But you're going to write git clone. This allows me, and I'm going to paste in the URL for ORFeed smart contracts. Okay, so I'm going to push enter, and it's going to create a directory called ORFeed smart contracts. So I can switch into that directory by saying cd ORFeed smart contracts, and now I'm in that directory. I can now click open, and this is where I am now. So we have our smart contracts, and then we have examples. Examples is where we're going to put in the future more node examples for doing things. The first one is just our basic node example. So we're going to be looking at that. Now, if you're not familiar with Node.js, it's a backend programming language. It's separate from Solidity, of course, and it is the piece that is going to call your smart contract whenever. So your Node application kind of sees what's happening in the world. Can look anywhere. Can Google stuff. Can find out the weather. I don't know. It can do a lot of really complex things with information out around the world, and then it can take that information. It can also read from other smart contracts on the blockchain, on the Ethereum blockchain, on the Bitcoin block, wherever, and then it can then call our smart contract. So we need something to call it. Now, manually, we could always go through with MetaMask or whatever, and if you're not familiar with MetaMask, I highly suggest that you pause this video, go learn a bit about it. But MetaMask is simply an extension that allows you to kind of, manage your accounts and interface with dApps or decentralized apps applications. So, for example, one that we created a few weeks ago is called Structured F. It allows you to go on a website like this, click on a button, create a package of multiple, this is a good example of DeFi. 0.02F, I'd like to convert it, and then it creates a pop-up for you. It allows you to just kind of log in and finalize that particular thing. So I can confirm this, for example, and then what I'll be left with, is a leveraged position in Ethereum and Bitcoin, as well as 80% of a portfolio in a loaned out asset that's going to earn me interest. So I have a hedged portfolio that just generated. So that's what dApps are. If you're not familiar with dApps, they allow you to do weird things like that without needing a bank account or anything like that. And you could just use your MetaMask wallet and do all that kind of stuff. But if you're not familiar with that, I highly suggest pausing this video, go and check that out. All right, so now let's go over and I'm gonna look at that clone that I just created. So I said that there's an examples folder. What you're gonna wanna do with this examples folder is copy it and then take it, and I'm just gonna paste that in over here. Examples. I'm gonna rename it to something else. I'm gonna call this my node trade bot. Okay. So this is like a separate application altogether, but we included inside the ORFeed smart contracts to help get people started. So as we continue doing these classes, you'll see more and more different examples in here that you can pull out and then create their own kind of application. So let me just get everyone started with how that works right after we go through this Solidity smart contract. So that node application is going to just do simple reading and writing. So this is what the node application looks like. We'll talk about this in a second, but basically it can take a wallet, it can take a private key, right? A private key just is the password to a wallet that might have money on it. So I might have money on this address, and this private key authenticates and allows me to control the funds that are there on this address. And then a smart contract address or a token address or whatever, we're going to interface with this contract We're going to load in some data about it. We'll talk about what an ABI is when we deploy our smart contract. And then we're going to load the smart contract up, and then we're going to call methods. So for example, we can get the price of DAI, or rather we can get the price of Ethereum to DAI. And then additionally, we can buy DAI. So we can actually go directly from our node centralized application, interface with the smart contract, tell it when to buy DAI, right? So we can have a timer that just buys it every hour. We can have something that looks for certain conditions in the world, like there's a tsunami in somewhere, and now we want to buy DAI. Whatever we want to do, then we can interface with that smart contract. And the smart contract can be endless. It could buy DAI, it could do arbitrage, it could go to, for example, structured, create a portfolio, whatever. And then after that, we'll talk about little functions. Like, for example, we're not really getting that deep into this, but we'll talk about kind of just calling the methods. And this is a really dumb application, meaning it does one thing really simply. It literally just gets data from the smart contract that we're about to deploy, and then it makes a trade. It calls the smart contract, and the smart contract makes a trade. So let's talk about the smart contract. The smart contract's here, and essentially we have address, DAI address. So in Solidity, we have data types. Address is a data type, and if you're not familiar with data types, that just means a type of thing. So there's usually integers, uint 256, so integers like number. String is words. Var is a collection of variables, a collection of addresses, or a collection of integers. In Solidity, usually they're called arrays in other programming languages. So we say, okay, we have an address, we give it a name, and then we paste in the address. So this is the address. If I copy this and I go to etherscan.io/address, and I paste in that address, I'll see that it is the, this is not the DAI stablecoin address. This is the DAI Uniswap market address. So if you look at this smart contract, this smart contract actually allows people to do token purchases, add liquidity. It's for this website, uniswap.exchange, where you can easily go in, and this is another dApp, and you could select any token. I have F, I want to convert it to AMPL or into, let's find a cool, there we go, Kyber network tokens, right? So I have this thing, I want to convert it to that thing. And in an easily decentralized fashion, without any middleman, I can do that. So I can do it here, and I'm in interface with their smart contract, or my smart contract can do it. But the thing is, my smart contract can do a lot of things with this exchange, with other exchanges, all in one foul swoop. So over here, I'm calling this marketplace, which is just the DAI marketplace, and then I'm creating the object. So up here, I introduce the Uniswap exchange interface. I'm just calling that interface, and we call this creating an instance of it called USI, and then I'm setting a parameter of the DAI address. So that just basically what this does is just creates the exchange. This one line of code, I've created an entire exchange. Isn't that amazing? And then I say the amount of F I want to use, and so msg.value, message.value is in any smart contract, the amount of ether that's been sent to the smart contract. And in order to send ether to a smart contract, you have to specify that it is payable. So if a function has the word payable in it, it means that it can be sent money and manage money and do stuff with that money. And then here, I just get the DAI token. Now this was the address I was mentioning earlier. This is the actual DAI token. So if I take this address and I paste it up here, etherscan.io/address/this, I actually can see all of the DAI transactions. So we can see that maybe 1 to 2 a minute transactions happen with DAI, right? Which is actually not that much, but it's quite a bit. And I can actually see the contract. So this is what makes the DAI stablecoin work. This is the Solidity code, and because you're learning Solidity, it's just what you're learning here, but a lot more functions. And just methods and things being called. So you'll be able to understand that pretty quickly, pretty soon. And if you don't already. And then, so what I do here is I create an instance of the DAI token called DAI token using ERC20 library, which I have up here. And then I do a DAI token dot, I use that object, I call a method called transfer. And then I transfer it to another keyword, msg.sender, which is the person who sent the money. So msg.value is how much money was sent. This is an address type of who sent the message or the money. And I'm going to transfer to them the amount I got back. Okay, so I did the transfer. And up here is actually the whole transfer. I sent over the amount. I called the exchange object. I said F to token swap input, which is just a function. I sent over the amount and I said, do it on this block now. And then transfer whatever I get back in DAI token to the person. So you send in F, I will exchange it and give you back DAI. And in the future, like we said, we might do a bunch of stuff. We might go to Kyber, take that DAI, convert it to C DAI, earn some interest, then send it back. I don't know, do anything. And I return how much I got back. And then over here, we do a thing, we have a function that's constant, which means that this doesn't cost anything to get the information. So this is free data that anyone can access, whereas this, you have to actually pay something, and you have to also pay gas, which is just how the Ethereum blockchain, what the Ethereum blockchain itself charges you to run a transaction. So there's free transactions, and then there's transactions that cost you money. Things that don't have constant in them are things that are going to cost you money. And constants are just things that return information. So for example, this one uses our ORFeed library, which is a platform that we created, that soon you can use to get all of the arbitrage opportunities. So you can use ORFeed to say, what's the price on this exchange? What's the price on this exchange? What's the price on this exchange? And then you can use a function like this to then interface with those exchanges using the Oracle data to then create arbitrage opportunities and whatever, and advance your learning into how smart contracts work. So in this case, I'm creating an ORFeed instance, calling the ORFeed Alpha Smart Contract, and then I'm saying, hey, get the exchange rate for F to USD, and I put the amount that I want to get. And the reason I use this large amount is because of the way decimals work. And so one interesting part about Solidity is that, which is the Ethereum Smart, which is what we're looking at here, is that there are no decimals. So for example, a number, if it had 3 decimals, if this number had 3 decimals, or if this number had 5 decimals, it'd be 1, 2, 3, 4, 5, and there'd be a period here, and it would be 1,000. So this number with 5 decimals is 1,000. This number with 6 decimals is 100. And so you gotta kind of have to learn to read numbers like that, like know how many decimals are in a number. There's a long, complicated story, but you could type in like decimal Solidity and learn like why Solidity doesn't have decimals. Essentially, decimals are just a figment of our imagination in the first place, because every number is just a number, and where we put the dot is kind of just in our minds, and we keep up with it. So Solidity kind of recognized that and works with that. So, and then this little one here, and you could put in who you want to get the data from. So Kyber, buy, Uniswap, sell. Whoever I want to get the data from, I put it here. So this is just like the average price across many. So I can say, okay, get the exchange rate. So and this will just, and it will return me the price. So this one's just so we could learn how to use and read functions. And I could, in a future thing, I might read from 20 or 50 different feeds. I might get the exchange rate on Ethereum, USD on a zillion different platforms, or BTC or USDC on a zillion different platforms, and then use that to trigger when to buy and sell things. So we'll show how to call these functions. Now, if you go to the smart contract up here, which we've left an address, so you can always go and see like, what's going on with the smart contract by going up here. And this original contract will always appear here because it's been verified. So here I can see the contract, and let me close all these tabs out because so I can go here and click on contract for this contract and look at the contract code. And Etherscan has verified that the bytecode which is just the code that's generated when I deploy the contract, matches this. And so whenever you're doing a smart contract, it's good to make sure that it's been actually confirmed by Etherscan and has the contract source verified exact match, because that means that the person who created the smart contract is being transparent with you about what's in it. And these rules can never change, which is really fascinating. But they can be updated if they're written to be updated. That's important also to always remember. All right, so that's a quick introduction to how that works. So let's actually get some of this to work, right? So yesterday we did one simple transaction over here, and you can see the transactions that we did by clicking on transactions. You can see that we sent this contract, and you can do that too by testing. You won't lose any money. You'll send Ether to it. It'll convert it to DAI, which is just USD. And then you could take that to Uniswap or wherever and convert it back to ETH if you want. So you can always use this smart contract to see exactly how this code works and to understand it. And additionally, you can interface with it directly by, for example, we have this here, this address. You can switch out the word address for DApp. And I'll do that. Instead of address, I'm gonna type in DApp. DApp. So what this allows me to do is read the contract. So all the constant functions, I can see here, get DAI price 183.20842883. So that's the exact value right now of Ethereum. And then I can do a write to the contract and then do buy DAI. And then I can set how much Ether I want to send. So 0.01 Ether, click write. It'll say connect to Web3. It'll probably give you a notification to do something over here on your MetaMask or whatever, if you're using Formatic or if you're using Portis or Tau or one of the newer different kind of things. I'll click write. And then this will send funds over to it. I'm going to make a high gas fee so it gets through the blockchain quickly. So the higher I pay in gas, the quicker it'll get confirmed. So I just sent that money over. And so you can interface with your smart contract the same way, but you'll need to verify the smart contract. So let's just do that real quick. Let's talk about how to spin up your own, because I know you're going to want to do that. So you just copy the code. You take it over to a place like remix.ethereum.org. So you can go to a website like this. Now, this is the new layout, at which case you can just click on, anywhere like this, and you could just paste in the code that you got over here. And then you can then take that and deploy it, right? So this is the UI that most people use. I'm going to use the old UI because I'm an old school kind of guy. I like the older version more, but use that other version that you just saw. Do it just like that. And I'm just gonna paste in the data. And you'll select the compiler. So we're using version we're using 0.426. Okay, so I'll select the compiler version. It'll give you a bunch of warnings saying, whatever, but it'll say that as long as you don't have any red in here, you can deploy that contract. I'll go over, I'll select run, and then I'm going to click the Uniswap trade example contract, and then click deploy. All right, and then you just say Heroku, git add a, not a repository. So in this case, what you'll need to do is to say git init to create the Git repository, so you can push this code up. If you're not familiar with git init, then just look it up. You'll learn what it does. So I'll do git add. This adds all my changes that I made. Git commit. This adds a note, added stuff to my commit, so I can always get back to this place. And then you'll do a git push Heroku master. There's no Heroku, and in that case, you just copy this URL here that they gave you when you created it, and you say git remote add Heroku. You give it a name. I call mine Heroku because it's on Heroku. And then I paste that in, and then git push Heroku master. And that magic ingredient will actually then deploy this to the free application that you just generated. Now the problem with free applications is that it'll shut off every few hours. But if you pay and you upgrade it to $7 a month, then it'll run continuously. So this server will actually run. It's a free server, so it'll shut down. So that kind of sucks for Node apps, because usually you're doing something 24/7 that you want your node to constantly be monitoring stuff. But just to kind of get you started on like how do you actually deploy this thing, I'll be able to actually go to this URL and do the same thing that I previously did. So I'm going to pull the window down. So then you'll see it in your list, and then you can just click Open App. And what you'll see is simply the example response that you saw previously. So there it is. And then I can go to /, and then I can call my function. So I can call the example transaction function, and it'll actually perform the transaction. So it'll say, hey, look at your console. And in order to do that, all you have to do is just type in Heroku logs in 50, see the last 50 logs. And this is how you can see your Heroku logs, just like you did on your local computer. So there you go. There's my transaction hash. There's the price of Dai, right? So there we go. We've deployed something. It was awesome. It was really great. I just created another transaction. My previous one went through. I sent money over, and it converted it, the very small amount. I transferred 0.00000001. And remember, in the smart contract code, we saw here that the example only sent, and this actually needs to be a really small amount. So a very small amount of, and I'll just, for the example, make this a little bigger for you guys in the future. So there we go. We just deployed a server that can read smart contracts, can write to smart contracts, as well as deploy a smart contract and facilitated a DeFi trade. So there's an intro. Like I said, this is probably a video that you'll maybe go back and watch a few times, depending on what your familiarity is. But in the next few videos, we'll go over more complex things that we can do to build on top of this to actually perform some arb or do instant margin trading or other different things that we could do that's unique and interesting in the DeFi space. So stay tuned for that, and thank you very much for joining us.